Hi everyone, this is going to be a new video. In this video, we are going to study about notification system design. This is going to be a very detailed video. That's why I'm mentioning the index here. So if you want to study something very specific, you can go to the exact spot and study. So without wasting any time, let's get started and study. So this video is divided into two parts. In the first part, we are going to see the channels, requirement analysis, storage estimation, and the problem that we are going to solve in the actual system design. And in the second part, we are going to see the actual system design of notification system. So let's start with the first point, that is channels. So you can say channels or type. So channel basically means by which medium you are going to send a notification. Usually there are 4 types of channels that we use, that are email, SMS, push notification or in-app notifications. So let's talk about the emails first. So let's say that you are on an authentication page and like someone write an email and forgot their password. So you will click on the reset password button. In that case, you get an email. That email that you are getting, that is coming from the notification service. Okay, that can be one example of an email. We can take one more example, that is like whenever you place an order on an Amazon, what happen that when your order has been placed, you get an email at that time. There can be one more example that you can take of email when you get in promotional emails every time, or you can say LinkedIn is sending the newsletters of the company. These are all the examples of email. Now let's move to SMS. So whenever you type your number on a login page, there is something that you have to send an OTP. The OTP that are going to come on your phone, they are going to come with the help of the notification service again. Whenever you perform any transaction, banks are going to send you a notification that your money has been debited, something like that. Now let's move to the third one, that is push notifications. Assume that you are not using the phone right now, and at that time that someone sends you a message or someone liked your post, and when you open the phone you see some banners. Those are the push notifications you usually get. Suppose that you are chatting with someone, at that time someone started following you. In my case, SRK follows me. So what will happen at that time? You will get a banner in your app. Or you can say, like, if you're chatting with someone else and your crush messages you at the same time. This is example of in-app notifications. Now let's move to the requirement that we need to fulfill in the notification system design. I just mentioned the one line here, deliver notification to user whosoever is subscribing the topic. So let's say you are following Taylor Swift. Then what will happen in that case? Whenever Taylor Swift is going to post a photo and you are following the Taylor Swift, so in background what is happening, that you are following the topic of Taylor Swift here, and whenever she is going to perform any action, like she is going to post a photo, she is going to comment on something, you will get a notification. So let's say you are on authentication page and you type a number. In that case, what is happening, you are going to subscribe an OTP topic, something like that. Now let's move to the capacity estimates. I mentioned here 1 billion topic. What I mean by that, so let's say that you are on Instagram, and what will happen at that time, someone is going to press a button on login page, there is other person who is liking a photo, there is someone who is going to comment on your name, there's something like this. And in many cases you are going to subscribe those topics, and there are many cases and the other friend is going to subscribe those topic, and many things is going to happen. So that's why I'm assuming that there are 1 billion topics, and let's say there are 1000 notifications are going to be sent on each topic per day. And after that, I mentioned that each notification will consume approximately 1000 bytes, or you can just assume that approximately 1 KB. So for the storage, it is going to consume 100 TB of data per day, and you can say 30 petabytes of data every single year. Now you're getting it, that company has to store a lot of data to send the notifications. Now let's move to the problems that I mentioned in the starting of a video, that while we are going to make a notification system, we have to deal with some of the problems, and we are going to solve those problems in our system design. So our first problem is important. So I mentioned an image here, that first image is of transaction and second is related to promotions. Some of our notifications are very important and some of them are promotional notifications. I want to prioritize the transaction notification or an OTP notification over the promotional notifications. I also mentioned one more thing here. Usually transaction or OTP notifications are one-to-one and promotional notification are bulk notification. Now let's move to the second point, that is the celebrity problem. So I mentioned that there are 3 cool stars like Taylor Swift, Ronaldo or Messi, that they are going to post an image on Instagram. When they are going to post a photo, what is going to happen? Like each of the followers or the subscribers are going to get a notification that Taylor Swift has posted a photo, Taylor Swift has posted a photo. Like each of them is going to get a notifications or not? This is the first question. I hope you are understanding the intensity of the problem. Let's say that Taylor Swift is going to post a photo and there are 300 million followers she have. In that case, do companies send 300 million notifications, or is there a better way? Second point of celebrity problem is whenever these followers are going to like the photo. So let's say Taylor Swift is getting 1000 likes in every single second. In that case, what will happen? Taylor Swift is not going to get 1000 notification in her phone. Her phone will die in that case. And so in that case, Instagram run some amazing algorithms. So in that case, Instagram find a way of aggregation that I mentioned it here, digest summary notification. So in that case, what we want, we need to send something like this, and 999 others liked your photo. This is the better solution, I guess. When I'm making this video, I remember that point when I was using the Facebook, it was something like that. Parth and 99 others are traveling with you. It was so funny. So now let's move to a third problem, that is vendor rate limiting. So let's say for SMS, we have the vendor is Twilio. For our push notification, usually use Firebase. So what happened? They are having some limitation that they are saying that we can only support 1000 push notifications per second. An SMS provider Twilio is saying that we can only send 1000 messages per second. So we have to keep this thing in mind. So let's think like this, that Taylor Swift again posted a photo, and in that case we have to send a notification, and we are going to send a notification to, let's say, 10,000 people. So let's say we are going to send the notification to 10,000 people, but we have to remember the rate limiting of the vendor. So we are not going to send a 10,000 notification in a single second. We are going to send the notification in batches or something like that. So we do not breach this rate limiting. We have to take this thing in our mind. Now let's move to the fourth point. If users are offline, can fetch their notifications later. So let's say if the user is offline and not using the phone right now. So there is no need to send a notification. As soon as the user is going to come online, he will going to get some notification. I don't know how I can explain this point. Let's say your internet is off on the phone, and when you are going to on the internet, at that time you are going to get some notification. That can be a simple example. Now let's move to the system design of notification system. I don't want all of you to be scared by seeing this big picture like this. It's going to be pretty simple. So first of all, let's discuss this left hand side of this whole diagram. So let's assume that we are in the system. There are a lot of services. Let's say there is an authentication service, there's an onboarding service, promotional service, or a post service. These services are going to send some notification. And how these services are going to send the notifications? Let's say someone posted a photo, and let's say someone is going to send an OTP with the help of this authentication service. Anything can happen. These services are going to generate an event whenever something happens. Now what happened? These services are going to send this event with the help of an API or an Kafka queue to the notification service. Now our one point is very clear, that notification service is going to get an event. So I'm going to write it down here, that notification service is going to receive an event. I hope you can see it, with the help of two things, either with the help of an API or a Kafka queue. Why I mentioned these two things? This is a second point. Let's assume the first case, that someone needs to send an OTP. In that case, what is happening? Like, you just want to send an OTP, you can just simply directly hit an API to the notification service and you can send the notification. But let's take another example. Suppose there is one more service, transaction service, and someone is doing a transaction. And suppose you send a notification, A has transferred that money, something like this. In that case, you also want to push that transaction to the analytics team, let's say. Now what is happening? Your transaction service is acting as a publisher, and the notification service and the analytics service are going to act as a subscribers. This is why sometimes we need a Kafka queue and sometimes we need an API. According to your need, we can just change it. I think this point is very clear now. And then now we are on notification service, and now we know very well that notification service is going to get an event. And now let's discuss what type of data we are going to get in this event. Okay, for that we have to understand the DB design of the notification system. So I'll just move to the database design, and we're just going to discuss a one table first of all, that is the notifications table. This is the table that we are going to discuss now. This is the notification table. So whenever we get an event, we are going to save it into our notification service after processing it. Let's see what we are going to say. Let's say there is one ID. After that there is a user ID. User ID is the one who is going to send the notification. Action ID, what are the actions that we are going to perform? This action ID and this template ID is going to be correlated. Object ID means that on which object we are going to perform an action. Let's say our user ID is 123 Action ID is like. Like means that someone liked your photo. Object ID means maybe a post, maybe a comment. That someone can like your comment as well, someone can like your post. Object ID can be CO underscore 1234, maybe a comment ID. Post ID can be PO underscore 1234. So for there will be a delimiter like it is a post, the like by a post or like by a comment, something like this. I mentioned two things here, actors and the total. Actors means that to whom we are going to send the notifications. Let's say someone liked your photo. In that case, I am going to get a notification and total count is going to be 1 because I am the only one who is receiving the notification. But let's say company wants to send a notification to 100 users. In that case, what will going to happen? User ID is going to be company's ID, and in that case actors are going to be all the 100 users list, and total is going to be 100 in that case. Okay, because many people are going to get the notification. Metadata is an important point. What happened? So here I mentioned the template. Action ID is going to connect with our template ID. What happened? Let's say we have to send an email or an SMS. These notifications and these template are going to connect with each other. Now what will happen? Let's say this action ID says that the type is email, and in the content body what will happen? Let's say in the content body I write my HTML in a way that there is some placeholders like that @email @. Now what will happen? The code will run and it will process the metadata and the content body and going to replace that @email @ with the metadata values. Metadata is going to be JSON. So let's say there is an SMS that is your OTP is 1234. That OTP equals to 1234. That value is going to come from the metadata, and your OTP is in the content. And after that, the value is going to replace with the help of this metadata in the content body. This is something that I'm trying to explain you. So now we came to know one thing, that we are getting an event, we are going to save it in a notification, and with the help of the template, we are going to get our desired message. And we also able to figure it out with the help of this type, that either this particular event is going to be an email, SMS, push notification, or in-app notification. But sometimes what happens that there is a user preference service. What is this service doing? This user preference service is going to tell that this user want emails instead of SMS, or you can also say that this user don't want promotional emails, something like that. In your mobile application, you can just go to the particular notification section and you can just turn it off. It will just change the value in the user preference service. So our notification service is going to communicate with the user preference service and also figure it out what can be the actual type by which we can send the notifications. Okay, so notification service is going to communicate with the user preference service, or with the help of this type variable we can able to figure out we have to send an email, SMS, in-app notification, or a push notification. There is one more point that I also want to cover here, that notification service also figure out this thing, that particular user is online or not, with the help of this user preference service. User preference service either make a connection with our mobile application that our user is online with the help of the last timestamp we have. In that case, what happen? Let's say if the user is offline, we are going to send the push notification, and let's say if the user is online, we are going to send an in-app notification in that case. Now let's again come back to the main point. We get an event, we store into our notification, we send it to the user preference, and now we also figure out the exact channel also. Now what is going to happen next? This notification service going to send all these particular notification to their respective queue. Suppose this particular notification is related to SMS, so it will send to the SMS queue. It is related to email, it will send to the email queue. It will related to in-app, it will send to the in-app queue. And they have their respective consumers that are going to connect with the vendors. Vendors, I already told you that there are some vendors like Twilio, Firebase, and many more. These vendors are going to send the actual notifications to the users. This is a very simple design of notification system. Now let's solve the problems that we have discussed earlier. So our first problem was related to priority. That was, so either it is a transaction event or a promotional event. So for that, again, we are getting an event. In that event, what we can do, we can add one field. Let's say field, either the type can be transaction, or we can say type can be promotional. Now our notification service know it very well that it is an important notification or a promotional notification with the help of this type. Now after that the same thing happen. Let's say notification service again figure it out that it is an SMS. Now we are going to talk about in respect to SMS. So please focus that I mentioned it here, two queues. First one is P0, other one is P1. So P0 means that it is it is a queue with high priority, and P1 means the queue with the low priority. So instead of using a single queue, now what we are going to do, we are going to use multiple queues of SMS. In the same way, we are going to use multiple queues of emails. Same way, multiple queues of in-app notifications, and we are going to maintain a priority. So first one is going to be P0. So what is going to happen? Whenever there is an OTP notification or a transaction notification, it will go to the P0 SMS queue. And whenever there is a, let's say, promotional notification, it will go to the P1 SMS queue. Now what will happen? We are going to make our consumers very smart. What I mean by the smart consumers. So consumers are going to be that smart that they are always try to clear the P0 queue first, because P0 queue is our the high priority queue. So what they want, first of all, they want to clear all the messages that are in the P0 queue. So whenever the P0 queue is going to be empty, they are going to read from the P1 queue. So in that way, so first of all, transaction messages will go, and after that promotional messages will go. Now let's solve the third problem, that is related to the rate limiting. So in the rate limiting, what I told you, that all the vendors have their rate limiting, that only you can send 1000 messages per second. For that, what we are going to do, I told you about the smart consumers. These consumers are going to consume a message in a way that vendor is supporting. So what I mean by this is, so the vendor is saying that I can only send 1000 notifications per second. So consumers are going to add a delay. Okay. So what we are going to do, we are going to add a delay in the consumer, that it means that we are going to consume only 1000 messages per second. So this is a queue, and the consumers are going to consume only 1000 messages per second. So it never bombards the vendor system. This is how these smart consumers are working. But there is a small problem. Sometimes it happens that these smart consumer fails and they bombard the vendor system. So what happened in that case? We reach the rate limiting and the users are not getting the notification. So in that case, what we can do, we can make a dead letter queue or a rate limiter queue as well, that will store all the notifications that weren't able to send because of this bombarded or we breeze the rate limiting. So we can maintain one rate limiter queue as well, okay, that we can read one more time if we are not able to send a notification at first. Okay, this is something that we can do. This is an additional configuration. So now let's understand this bucket as well. So what we are going to do, we are going to use a blob storage. So we are going to send some emails and we are going to send some images. So what happened, this particular template needs some sort of an HTML file or an image. So we are going to store all these HTML or images in this S3 bucket. And whenever we are going to send this notification, we are going to attach the HTML file or an image file to our notification while we send it. That's why I just put this bucket here. Now let's understand the scheduler service as well. So I'm going to share a very simple example with you. Let's say today's date is X and Prime Day sale in Amazon is going to start on X plus 30 days. Now what Amazon wants to do, Amazon wants to send the notification to all the users that are using Amazon on X plus 15 day. In that case, Amazon needs to schedule the notifications on X plus 15 day. So with the help of the scheduler service, they are going to just put all the notification on a schedule on X plus 15 or let's say X plus 16 day. And so all the user will get a promotional notification of this Prime Day sale. Now, let's come back to the database again. We have discussed this notifications. We have discussed this templating and how they are connected with each other. Now, we also discussed the user table as well, I guess. But I think you didn't able to understand it. Why? Because we are going to communicate with the user preference. I told you about that. We are going to figure out that the user is online or offline, or we can say that this user preference is either going to be email, SMS or anything. We are going to get this particular data from this user table. This is how the user table is going to be. This is a pretty simple table. It's going to contain user ID, name, email, phone number, device token. So device token, or you can say it as an FCM token. So whenever you need to send a push notification to a device, in that case, what is going to, so you need a FCM token to send to a device. So we usually store that FCM token in our database, and whenever we need to send a push notification, we send it with the help of this FCM token. Last CNAT is going to tell us that this user is online or off. Let's say that it is a simple mapping that I'm keeping it here, and this is going to be updated. This last CNAT is going to update it with the help of the user preference service. Now let's solve the third problem. In the third problem, what we have studied, that what is going to happen when there are a lot of people are going to like the photo of Taylor Swift. So what type of notification that Taylor Swift will get. Let's say this is the example that I mentioned it here. Let's say Rohan liked your photo, Priya liked your photo, Aditya liked your photo, Neha liked. So let's say that I'm getting lot of notifications in that case. Now what will happen? Will I get all these notifications, or will I get something like that? Rohan and 5 others liked your photo, and now we know it is a like event. Instead of storing into a directly into a notification table, we are going to take this event into aggregation event. Okay, so here also I made one table that is for likes, follow and comment. So what is happening here? Whenever there is an event, or you can say this action ID is going to be saying that it is a like event or a follow event or a comment event or something in which we need an aggregation. Instead of directly putting into a notification, we are going to put it first into an aggregation table. Notification underscore aggregation table. That's what I'm doing it here. I just put all these things into this notification aggregation event. I just make them entry. User, it is the same tables. It is somewhat the same table. User ID, actor ID, actions, object ID, and every single thing. So what is going to happen in this case? I am going to run a cron for this particular notification aggregation. Let's say in every 5 seconds, I'm going to run a cron in every 5 seconds and try to figure out that the similar kind of notifications, okay, that are come, let's say that are come under 1 minute or 1 hour. Okay, so let's say user ID, action ID, object ID, I aggregate them in a notification raw. I just wrote it down, notification raw. Let me just change it to notification aggregation, where created at is going to be now minus interval 1 hour. So I'm running the cron here. After that, we'll group on the basis of the user ID, action ID, and object ID. Whenever we are going to run this kind of a cron, now we know Taylor Swift get 1,000 likes in 1 single minute. After that, we are going to make one single entry into our notification service that consume our user ID, likes. Again, the like is our action. Object ID for the post that Taylor Swift has posted. Actors. So here are the 3 actors. Let's say there are 1,000 actors, and the total is going to be 3. In that case, the total is going to be 1,000 and last updated at time. And this is something that we can do when we are going to use the concept of this aggregation. We can run a cron in every single second. We can run a cron in, let's say, every single hour, every single minute, something like that we can do. So I mentioned the cron example here that we are going to run an aggregation, but there is a better solutions as well. Think about it. So we covered almost every single thing. We covered the problem of priorities. We covered the problem of rate limiting. We solved the problem related to aggregations. Now we are going to solve the first part of the celebrity problem. That was when Taylor Swift is going to post a photo. In that case, will everyone get a notification, or is there a better way that this Instagram or a LinkedIn are going to use? Now, for solving this problem, we have to understand one point. That is fan out on write and fan out on read. If you understand this point as well, you will able to understand almost complete notification system. Everything till now that we were studying was a part of fan out on write. Let me just make you understand it. When Taylor Swift posts a photo, the notification service immediately sends a notification to all her followers and stores it into the notification inbox. Let's say that I am having 10,000 followers. What will happen whenever I'm going to post a photo? What will the Instagram will do? It will just trigger an event by the post service. It will reach to a notification service. It will figure out that I am having the 10,000 followers. It will just make a 10,000 entry into my database, and it will send the notifications to all the followers that I am having. Till now that what we are studying was a part of the fan out on write. That's what I'm trying to say. Taylor Swift post a photo, but she get 100 million followers. Okay, this is the only point. I'm just giving you the example of 10k followers. That was my example. Now what happened? The pro is what? It is very fast. It's a very simple pro that is very fast, that everyone is getting the notification. But let's say this number is increasing in the case of the Taylor Swift. She is having 100 million followers. Now the thing is, instead of making the 10,000 entry, we have to make 100 million entries in that case. That is going to be very difficult. It can put the whole server down. Your server will become slow. And so let's say if the Ronaldo is going to post something, we are not going to make 100 million entry or 600 million entries in our database. We have to come with some smart solution. For that, we have to go to the second solution, that is going to be fan out on read. Now let's understand fan out on read. Whenever you open your apps, the system generates the notification by checking who you follow and what they posted. So Taylor Swift posted a photo and we didn't send a notification to you at that time. Now you open your Instagram app, and whenever you start seeing your posts or reels or anything, at that time Instagram will figure it out, the people that you are following. let's say you are following 500 people. At that time, what will happen? It will figure it out that you follow Taylor Swift, you follow Ronaldo, you follow Messi, you follow Sachin Tendulkar. It will just figure it out. At that time, they will figure it out, the post that they have posted, and by that data, they are going to send you the notification. That is known as a fan out on read. So there are cons in that as well, that you are going to get a lazy notification, and companies in that case also have to do some high computation. That first of all, they will figure out all your followers, and they after that they will figure out that the post that they have made, and after that they have to figure it out that they have sent you the notifications or not. Accordingly, they have to send the notification. This is the whole process they have to do to send a single notification, but it saves the server. Now the final conclusion is the companies are using the hybrid approach. Whenever there are small or medium account, let's say up to the 10k or 50k, they can go with fan out on write operations. They can just simply send the notifications directly. But whenever there is a celebrity or an account that is going to consume, let's say, million of followers, in that case they are forced to use fan out on read mechanism. That is an important point. So I think I covered all the topics related to notification system design. We saw a lot of problem. It is a generalized notification system design, and there are use cases the companies are solving accordingly. But I try to cover most of them, and I'm going to share all the notes and a diagram in the description, so you can just go and watch it. And thank you for watching me, and bye bye.